Okay, so we are in discussion with for similar design pattern, and we discussed about builder and bridge design pattern. So generally, all design patterns they are based upon polymorphic behavior. Either it is in inheritance or it is in containment. So builder design pattern and bridge design pattern, we saw two classes that are showing polymorphic behavior. So that is the idea. Now we land up into different kind of scenarios. There are many scenarios that 23 GOF design, 23 design pattern they handle. So one of the scenario we talked about that two classes they are handling polymorphic behavior. Other scenario is like single cell organism like amoeba or euglena, okay, or bacteria. So it is not in control of a human to clone it. Okay, it's not possible. Means if human wants to get it cloned, but it's not possible. Means cloning happens in amoeba, bacteria, or euglena internally. So it's a single cell organism, and plus first the nucleus would become 1 to 2. It will get kind of divided. Okay, then cytoplasm, first nucleus, then cytoplasm, and then it will become a mother cell become two daughter cells. So that is internal cloning that happens in single cell anemia. So this is also called, I believe, kind of meiotic division. Okay, meiotic division. So this is kind of comes under that scenario, or or in better term we say binary fission. So binary fission is a mechanism where a single cell organism like euglena, so nucleus and cytochondria it be 1 to 2 it divides, and from one mother cell to two daughter cell it happens like this. So it is something like it happens internally. Okay, so this is one scenario. Other scenario we talked about like our body. Our body has many mechanisms like circular, respiratory, muscular, neural. Okay, then a skeleton, bone system. Like that, we have kind of many subsystems, and they work internally. So muscular system has nothing to do with neural system as far as any recovery is concerned or growth. Muscular system will grow on its own, or kind of other systems are also possible. Okay, so so means they have internal structure very strong. So now I think it is disclosed. So we are talking about scenario where there is external and internal, intrinsic and extrinsic. If that is the case, then we find two classes that are similar to each other is flyweight design pattern and prototype design. So prototype design pattern falls under creational design pattern, and whereas flyweight design pattern falls under structural design. So flyweight design pattern. Now, when we see kind of scenario where we have two kind of scenario. One is that whatever the attribute, whatever the feature. So we sort all the features. So when we do kind of a functional specification to design a specification, when we convert the requirement to functional to design a specification. From functional to design a specification, when we try to kind of convert, then we see all the features available. So there are features which must be different, means they are different among all the categories. So they are called non-shareable. They cannot be shared. Like muscular system cannot be shared with the neural and then circulatory and then respiratory or bone system. So or endocrine system. So all are different. So they cannot be shared. But what can be shared? A shareable component among the kind of various features and non-shareable. Shareable like they all can get signal from brain, so that is shareable. So that component. So once we kind of divide something in shareable and non-shareable, Then non-shareable, if there are 10 non-shareable features, then 10 class it would be because they are non-shareable. So non-shareable feature they become internal characteristic of a class. Like a circular system has complete different architecture from inside. Neural different. I mean, we have different doctors. Neurology is separate, and then bone doctor is a kind of orthopedic is separate, and then muscular is separate, respiratory is separate, ENT, and skin is separate, skin specialist. Okay, ophthalmology is separate. So we have separate department because every class, when we talk about non-shareable component, when there are 10 different non-shareable components, and that leads to 10 different class. 10 different class have totally different internal structure, different internal kind of mechanism. So now the classes are divided among internal and external. If external is similar among all of them because they get a control from brain, so that is external for them because all they can share the brain. Like brain is saying a neural system, we are finding trouble in you. Can you heal yourself? There is some problem in neural system, and neural system got a hint that it has to heal itself. Now it started healing it. Muscular system, you have to heal itself. Or bone system, you have to grow. Like if a child is growing, then its job is to grow. His bone will become larger, larger, larger. So every kind of class, their internal structure is different, their work is different. External structure, they get hint from the brain. They keep getting hint from the brain. Okay, so if this kind of scenario happens where internal and external components are different, and plus internal component is very heavy, very strong, and it is capable of doing the work on its own with very little interference from the external, that is like brain kind of thing. So this kind of scenario leads to internal, external, intrinsic, extrinsic. Okay, so this kind of okay, like in Einstein theory also, internal energy and external energy. So if that is so, but provided the internal energy or internal structure, internal mechanism, internal work, or internal algorithm, whatever it does, it should be around 90% of the case. 10% should be guided from the outside. So extrinsic should be as less as possible. Now, if that is the case, then body is built. Now, all the system, okay, respiratory to circular to endocrine system to skin system, all they work in their own, and very less they get signal from the brain what they need to do. So that is the guidance from the brain. Okay, like if I am walking, my leg is walking or my hand is doing like this, means it is doing on its own. Suddenly it gets instruction from brain that now it has to do like this. Then brain is silent or brain is doing something else, but it is keep doing like this. So every system works on its own, and it changes the kind of work as per the external guidance, and then it keep doing that. So that is external and internal. So two classes that are very specific to external and internal. One is prototype that falls under creational design pattern, and one is flyweight design pattern that falls under structural design. So creational flyweight design pattern we understood that how we divide classes, in how we divide our problem domain into solution domain or design domain when we have so many classes, because every class has internal state as different and cannot be shared, like we talked about circulatory and respiratory. And whatever can be shared among all the classes is passed as extrinsic variable to the either class constructor or as a function parameter. Then it can start working. So this is private design pattern. Okay, internal, external. Internal is class attributes, and external is passed through parameters. But 90% code should be internal. Minimum code should be external. So that it should not keep doing external work only. It should be, if it is its internal state is very high, then it creates shareable component and active component. The way It is going on in deep learning kind of scenario in machine learning. So we expect all the kind of modules to be modular, to be adaptive, and to be active, not passive. Okay, so they can adopt to, they can fit in every places. They can learn on their own. They will learn on their own only when their internal strength is very high. So 10% only hint should be provided from the outside to learn it. Otherwise, 90% it should do on its own. So if that's the way our, so human is most powerful human is when its organs, its systems are internally they are powerful. Means anyone say that you should be powerful from inside. Okay, so a person is powerful from inside when it's all the classes. I mean, all the systems are powerful from inside. They take a hint only, minor hint from the outside. That's it. A person who is highly outside, everything he looks outside, certainly he is not a powerful. So that is flyweight design pattern. Extrinsic and intrinsic. Each classes is divided, means problem scenario is divided into design scenario with so many different classes because each classes have features and they all features are non-shareable. All features are non-shareable among the classes. That's how classes are divided among so many classes. Shareable component they come as extrinsic and non-shareable they become their intrinsic, and extrinsic is provided through the parameters, function or class parameter whatsoever. Now we'll talk about prototype design. Very interesting. So prototype design pattern is a creational design. Means if I need to create a, if I need to instantiate a class, or in very good term, if I say if I need to clone an object, object is already there. Like there can be scenario where object is very complex. First time I created the instantiated a class, and it took a lot of time to kind of parameterize or feed different things, and then initialize and then make it running. It took a lot of time, probably minutes or hours, to a big system to come up. Now I say, can you do? Now I am saying new again, not means if I do new again to the dead class, then again lot of time would go in bringing it up, a new object. So if object creation is complex, in that scenario, we generally we don't we don't kind of instantiate our own. So object, we have a class, we have an object, we instantiate the class to receive an object. One object comes up and bringing an object a tough time, then generally we provide feature inside the object itself to clone itself. Object is creating another object of its own type, means belonging to its class. So this is prototype. Okay, so if class A has object IA, then class A again I want to use to create IA2. IA itself will provide a function called clone. If I call it, then I from IA I'll get IA2. From IA I'll get IA3. From IA2 I'll get IA4. So they are responsible. Objects are responsible to create objects like this. Well, this is, if that is the scenario, we are talking about objects itself. They are responsible for creating their own cloning. Means actually, in better term, even better, their objects are responsible for creating the object of their classes. So we call it cloning. If that is the scenario, it is completely internal now. From outside, we can provide a hint that we need an object. Okay, that hint via media it goes to the object itself, and it creates an object like it, and it because it has all the states, all the attributes of the object it initialized to some variable, and then it creates an object of its type and then feed all the data structure. So only object can fill all the data structure. In real life example, we see like a single cell organism like bacteria or kind of euglena or amoeba. Okay, if I want them to be create like them, if I want them to create like them, they would do it on their own. First, they will make one nucleus two. Then mitochondria they would kind of divide. Then from one mother cell, two two daughter cell would be created. Okay, it is called binary fission. Okay, or mitotic division. So, kind of if this kind of scenario, so that is the good case example. Now, as far as design is concerned for the prototype, so if a class is providing a clone function, okay, then class can be abstract class, like single cell organism is an abstract class. From that we derive euglena, bacteria, and amoeba. Now, the interface class has a function called clone, pure virtual class, and clone is provided by all these three. Okay, I cannot say amoeba that can you clone yourself. Amoeba clone itself. Okay, so kind of I cannot call it. So direct coupling is not allowed here because we are making things intrinsic, internal. Okay, if I want someone, if someone is highly internal, means its internal component energy is very high, and it does not provide too much or does not entertain too much external hindrance. In that scenario, we cannot simply call clone and neutral clone. Okay, so we decouple. So the objects which can clone themselves, it's from the client. Cloning cannot. If cloning can be called, then it can do new also. Okay, in those kind of scenario, clone should be called kind of through privately. This clone itself should be kind of a protected function. Means no one can call clone so quickly. So there are two scenarios that can be done. One is clone, we make it protected, and in the interface class, we can provide a function something like please provide the type you want to be cloned, type and clone. If someone say that I want kind of amoeba to be cloned, he can just say amoeba, and then there it will search where is amoeba object, and then it will call clone. So clone is protected to the base class, even though it is driven, but it is protected to the base class. So finally, through each hash, the derived class clone should be called, and there it would do whatever it can do to get a new object. So that is the kind of design. So now the base class provide interface like type and clone, these kind of things. But how it knows that how many objects are available? Because it has to call the finally the object. End object will be called for the cloning. So whoever is instantiating the derived classes, they would physically each object who are instantiating each amoeba or each amoeba who want to be cloned, or each euglena or each bacteria who want to be cloned, the object, they would register with the interface. So interface class is not only interface class, it will have an list attribute which will be list of objects, and these objects they will register with the base class. Now base class has kind of a template methods and plus the all list of all the objects which can be used for the cloning, and it can provide now external function type and clone, type, type and clone. Someone say amoeba, then it will search in the all the available objects that want to be cloned, which one is amoeba, through some way, through some registry way, and it can say amoeba box can you clone please, then return the object. Now object is polymorphic. Okay, so object is polymorphic. If someone is returning amoeba, but clone would not return amoeba pointer, it would return its own pointer. So interface pointer. But since amoeba derives from interface pointer, so through polymorphic return type, the interface pointer would return the actual. This is one approach. Other approach is through factory method. There is a separate class. There is prototype interface class. From there, amoeba, euglena, and bacteria are derived. And prototype has a function control. Now it is a public function. And there is abstract there is a factory method which provide function like create, get, clone object, something like that, and it has list of all the objects. So at the beginning, it would create the list of all the list of objects, which can be cloned. Now through factory method. Factory method means a method which behaves as a factory to create something. Now if someone calls, can we type date or integer one? One means amoeba. Now in one section it will check one means amoeba. Now it will go to object list the way in the first approach the interface class was keeping the object list. Now factory method is keeping the object list. Now amoeba. Now it will go to amoeba and it will say please clone yourself and return the I point. Okay, return your object through interface point. So this way, so one of approach is base class itself providing clone method, and then it maintains the list of all the objects that can be cloned. So all the objects and the first go when they are created, they register themselves with the parent interface class and they make them available in their list. So if someone says that can you please clone this type of object, it searches in the object list and then it calls the clone that is a kind of protected, and then it gets back the clone through the polymorphic pointer of its own time. Or there is a factory method dedicated, it keeps the list of all the objects and and factory method to get it cloned. Now factory method someone calls passing some number or something like that. So idea is that actual object should not be called for the cloning. It should decouple the cloning functionality. Either it should happen through the base interface class or through factory method. Okay, this much was not required, but anyway, means for the sake of completeness. So idea is the internal and external state. So classes which are happy with their heavy internal state, they don't want to be exposed in the external states. So there we use this kind of creation. So flyweight design pattern falls under a structural design pattern because it is just a structure. Everything is ready-made, nothing is created. Only need to structure shareable and non-shareable, and non-shareable as different classes, and shareable as extrinsic parameter. So non-shareable become internal attribute, internal power. So it falls under structure, whereas prototype creates new object, new clone. So it falls under uh, creational design. Now we know the power of external and internal. So in creational design pattern, when prototype comes, external power is through factory method or through the base class. So these two classes, they provide external hint they receive from the client, they decouple the client from the actual object who clones it, and then that hint is finally provided to the object which would be cloned, and the cloned object is returned through the interface pointer of the base class, and so only single clone function works. Please use it.